things. I had the schedule written up. I should have written it over here, but I'll put it here anyway for this half the class that's not here yet. We're in week 9. I call this semester a 16-week semester. The school calls it a 14-week semester. So if you hear them say, well, finals week is week 14, it's not. So because I count spring break as a week and I count finals as a week as well. So today we're doing 4.3, which is an F prime and an F double prime test. Week 10, we will have quiz 13 and 14. We're going to do a practice for quiz 13 and 14 today, right first thing after I talk about the schedule. Week 11, you're going to have a homework 5 due. That's our last homework. So that'll be chapter 4 only. I do not do homework in chapter 5, mostly because I get bored of looking at your homework, right? Because you're supposed to do it. It's supposed to be right. So why should I even have to look at it by the time we get to the last chapter of the book, right? And so we'll have quiz 15 and 16 there. We'll have quiz 17 and 18 here, right? And so this is a 4.2 local min-max. This is 4.3 first and second derivative test. This is 4.6 optimization. So those are the last quizzes I'm going to give you. Week 13. Week 14 is your second midterm. So that's on a Thursday, right? We review on a Tuesday, and then we'll take our midterm 2. Remember, that first midterm, if you did poorly on it, it could still be wiped out by your final exam grade, right? So you still have to know how to do it. On the final exam will be every topic. It will be long, right? Week 15 is a review for the whole semester, and that school-wide Calc 1 quiz that's happening on Germantown, Rockville, and here. I think it's 5 problems. I'm pretty sure it's 5 problems, and a couple of them tricky. You'll have to think, God forbid, right? And then week 16 on that Tuesday is our final exam. I think it starts at 8 a.m. I think our exam starts at 8 a.m., which is a little weird because we start at 9, right? But for final exam week, I think we start at 8. But I'll double check it. What's that?
How long is it?
2 hours. Yeah, so it's shorter than our actual class time. Our class time is 2 hours and 15 minutes. But when I give midterm 1, it was 2 hours. When I give midterm 2, it's 2 hours. When I get to final, it's 2 hours. Yeah, and I know, right? We were talking how speed is an issue, right? If you think about it, if you didn't get your first midterm done or you ran out of time, you got to be careful of that. You got to really be conscious of 10 problems in 120 minutes, 12 minutes a problem. 1 or 2 questions could be real quick, and then you store up a little time for a more difficult problem, right? But and in that case, you got to practice with speed. You simply have to practice with speed. You got to set your clock, your timer on your phone or the kitchen timer or whatever, right? And make sure you're putting yourself in that testing situation. So anyway, that's looking like our schedule there. So let's do 2 practice problems for our quiz next Thursday, right? Ready? So we're going to do, so this is a quiz 13 practice. Let's find the absolute min and max of f of x equals negative x square roots of 5 minus x on 1 to 5. Good. On your mark and set, go. And remember, you want that kind of checklist on your formula sheet, right? Checklist says, draw the graph. So once you draw the graph, right, it's pretty easy to see where the min and max are, right? Do you see it already? See, the calculus is very easy, right? But doing the actual algebra is not, right? We're used to that by now, right? It's like, shut up, Robert, stop saying that. What's that? Yes, negative x times square root of 5 minus x. So we should all be writing. Beyonce, I recorded everything from the beginning, so. So step 1 was draw the graph. No, recognize. Step 2, get the derivative. Step 3, get the critical values. Oh no, step 1, draw the graph. Step 2, find the endpoints, right?
How come you draw the graph first if you don't know the sequence?
Say it again.
Like,
Little. I gotta put my ears in. Say it a little louder for me. Yell.
you say like draw the graph for
Yeah.
the first step.
Yeah.
I mean like if we don't know the sequence, how do we draw the graph?
Use your calculator. Calculator draws it for you.
Oh.
Right? It's kind of, we're cheating a little bit with the calculator, but so what? It's 2023. We don't have to do this like it's the year 1799, right? So we're going to use the technology to help us. No calculators, but you're still, if you took it there, you would still be practicing with your calculator. You understand that? My calculus class that I took, whatever year it was, I had a computer in front of me. We did everything on the computers. So different thoughts on that. But you're still going to practice with it. Even if you went to UMD, you'd still practice with the calculator. So step 1, find the value of the endpoints. Sorry, step 1, draw the graph. Step 2, find the value of the endpoints. Step 3, find the derivative. Step 4, and the critical values in the open interval, right? And then find the value of the function of the critical values, and then make a conclusion. So this is our first problem today. We're practicing for the quiz next Thursday, right? And this is from section 4.2. Anybody get that derivative? Travis, you get that derivative? Okay, good. Maria? Yeah, you probably just forgot a negative or uh-huh. Jorge, you get that derivative? Okay, keep working. Min, you get the derivative? Yes, good. When you're finding critical values, right? So we got our derivative here. Right, we got our derivative. When you're finding critical values, you're looking for the numerator equal to 0, right? You're looking for the derivative equal to 0. That means numerator equal to 0. You're looking for the derivative to not exist. That means denominator equals 0. But you want those critical values that are in the open interval. So if you get a repeat of an endpoint, you don't care about it. Why? Because we're finding the heights of these values, and we already know the height at 5. So even though it was a critical value of 5, I already know the height of 5, because I did it in step 2, right? Find the value of the endpoints. Yes?
So why doesn't that
I think you're asking me why don't we care about this one, right? Because I found a critical value of 5. What do I do with my critical values? I plug them into the function again, but I already found the function at 5. So I don't care about that critical value.
Oh, so like I already have that one.
That's right.
I don't
That's
need
right.
that.
You already know at 5 the height is 0. How did we get that critical value? Anybody get that critical value? Anybody get that critical value? Nice. Nice. Two of you. Ninja, yes? No, still doing the derivative? Okay. Jorge, you get the derivative? Did you get the derivative? You got the same one as me? Beautiful. You got the critical value.
Is the critical value one of the final things you just did?
No, just the 10/3.
Yes, sir.
Okay, good. And then you plug that 10/3 into the original function. What did I say for section 4.2? I like problems. I don't remember. I said maybe up to 71. Did anyone write it down? What did I say? What problems did I like for section 4.2? I didn't say it. I'll tell you which problems I want you practicing. Of course, you're going to go to all of my chapter 4 tests and do all of the absolute min-max, all of my final exams do absolute min-max, right? Every problem I've ever tested on, you should make sure you can do. How we do here? Nice. I want to check on the graph. Let me show you a quick way for you to be able to check on your graph again. Right, so on my calculator, I'm doing a y equal, right? So it's what, negative x times the square root of 5 minus x. I'm going to zoom standard. Hopefully you've looked up how to do a piecewise on your TI 8384. Do you want to see me do a piecewise on my TI 8384? No, Robert, because I already learned how to do it myself. TI 83 piecewise graph. So I do the function divided by parentheses domain. I'm just looking at one of these right here, without having you be able to see it. I do function divided by parentheses domain. So I go from 1. The domain is in math. No, the domain is in second math. I think it was parenthesis, but let me just see if this works. 1 less than or equal to x less than or equal to 5, close parenthesis, and hit my graph again. No, it didn't work. Sorry, I have a TI-84 anyway. Right. Oh, parenthesis, sorry. So now let's see if I can do this without screwing it up. So I want to insert parenthesis. There we go. And I want to get rid of that. I want to delete that. And then I want to insert parenthesis. Shoot. I'm just going to type it over. It's easier. So parenthesis function negative x square root of 5 minus x. Hey, morning. Close parenthesis, open parenthesis, 1 second math 6 x second math 6 5 close parenthesis. Please work. This is why I didn't want to do this, because you can just do it yourself. Damn it. Oh, what happened? Did I delete everything? Oh my God, what am I doing? Anyway, you look it up. I hate doing this. But I found my min at negative 10 square roots of 15 all over 9, right? So I'm just going to graph that. Y equals negative 10 second square roots of 15 escape divided by 9. And so I want to just see this, where this horizontal line comes through, and does it hit that bottom part of the graph? Right? Yes, you with me? On Desmos, it's just so much cleaner. I'm teaching Calc 2 and Summer 1 in a computer room. So we'll do all of this stuff on Desmos. And Summer 2, I'm teaching Calc 1 in a computer room. We won't use the TI-83 at all. I hate it. It's a dinosaur. Nice. So if you came in late, we talked about our schedule. Right, a schedule's there. I recorded it all. And we're doing a practice for quiz 13 right now. Now we'll do a practice for quiz 14. We ready? Maria, what do you need? Do you need the picture of the problem? Do you need this page, picture-wise? No? Okay. Okay, let me give you 2 pieces, okay? Maybe 3 pieces. There's the first piece. You got it? Good. Second piece. Got it? Good. Third piece. Yep. Good. Yep. Good. Let's do another practice. I'm going to give you a trig. I'm going to ask for critical values. Okay. So this is a quiz 14 practice. I want to find the critical values on values of y equals sine squared x minus cos x on 0 to 2 pi. Closed at 0, so including 0. Open at 2 pi, so don't bother including it at 2 pi, right? So first thing I'm going to do is graph it. Second thing I'm going to do is notice, right, where I should have critical values. Third thing I'm going to do is find the derivative then find the criticals, right? And that's pretty much it. You know, if I'm asking you the same problem with an absolute min or max, that I have to go and find the actual heights of the function as well. So we'll add that little piece to it. So I graph the function. Of course, I like zoom trig for this one, right? So I've got some value here, some value here. It looks kind of like that. How many criticals do you see? What's your guess on the number of criticals? 3 is a very good guess. It's actually 4, because I'm going to get, it's hard to realize it, but there's a horizontal tangent here, 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 and here. And in fact, if I included 2 pi, I would have had 5 criticals. It turns out that this particular point is the absolute max, a min. It's also called a local min. This one here is just a local min. Does that make sense? Local min meaning I'm at a low point compared to anyone close to me. Yeah, question? So when I graph, so I'll graph that one on my calculator, right? So y equal clear. So I got what sine of x close times sine of x close minus cos of x. And I want to zoom trig, right? So zoom 7. And a nice way to do piecewise, by the way, instead of doing what I was trying to do before, I can just cut off my window from the piece that I want. So meaning I go to window, right? And I make my x min 0, and I make my x max 2 pi. And so then that's the easiest way to do a piecewise. But when I only have one piece, if I have 2 pieces, I have to use that other process, which I've done in the past. But go find a good YouTube version of it and then do it. So there's my piece. Yes. Travis, you got it? Yes, nice. So, come on, hide. There we go. Who's got our derivative already? Who can read it to me? Derivative. It's really quick. Derivative, right? What is it?
Cosine squared plus sine.
Okay, so sine squared is the inside function is sine. The outside function is square. So when I take the derivative of a square, I get 2 times the inside function, and then times the derivative of the inside function. Derivative of sine is cosine. That same problem was on your midterm, right? Your first midterm. So you have to be able to do that derivative. And then derivative of cosine is negative sine, so I get plus sine. Good. When I'm, just like in pre-cal, when I'm solving these for 0, I want to factor if I can. So I can see I can factor out a sine x, and I get a 2 cos x plus 1 as my second factor. And remember, when you factor something, if you're in doubt, distribute it back or graph them both, right? Graph this one in y1, graph this one in y2 on your calculator, and they should match, right? Every time you factor something. If you're kind of bad at factoring, and then check yourself. Don't just do it blindly and assume it's correct. Check. So I want to find the critical values. Say again? Yeah, no, because all I'm doing is finding criticals. Sign.
Is it possible to have more than one local element?
Yes. Yes. I try and not give you functions with too many, because it takes longer to work on the problem. This one, I'm just asking for criticals, and it turns out there's 4 criticals. So what? That's fine, right? So I try and think about those things when I'm creating questions. So I need sine x equal to 0, and of course we know that from our pre-cal days, right? Quick graph of sine starts at 0, goes to 1, back to 0, down to -1, back to 0, right? So I can see really quickly my sine equals 0, which I'm going to get x equals 0, pi, and 2 pi, but I don't care about 2 pi, right? Yes, you with me? Yes, question? Yes. Derivative of cosine is negative sine, but there's a negative in front of my cosine already. So coefficients go for the ride, but double negative becomes positive. Yep. I also need 2 cos of x plus 1 equals 0, which means cos of x is -1/2. What reference angle works for cos of equal to 1/2? Pi over 3. Pi over 3. Yes, you're giving, I'm just asking a reference angle, right? Pi over 3. So I cut pi into 3, which means cut the whole thing into 6, right? And I'm looking for when cosine is negative, that's quadrants 2 and 3. So I know I'm going to have a value at 2 pi over 3 and 4 pi over 3. So so my criticals are x equals 0, 2 pi over 3, pi, 4 pi over 3. How we do? Do you remember solving equations like this in trig? I'm sorry, in pre-cal? Give me nods. How come my other 2 pre-cal students aren't nodding? How did I get pi? Look at sine. When is sine? Look at my graph of sine. When is sine equal to 0? Look at my sine graph, right? What are these 4 tick marks called? The quadrants, right? The quarter steps, yes? So 2 pi over 2 is pi, 3 pi over 2, 4 pi over 2. So I can see sine is 0 at 0 pi. Every k pi, right? Every pi. How come more of you don't remember doing problems like this in pre-cal? That's why we tortured you in pre-cal with all this stuff. So when you got here, it would be easy. Yeah. When x equals 0? So my cosine curve starts at 1, right? Cosine curve starts at 1, yes? So, and when I'm asking for cosine of x equals -1/2, that's what we're talking about, right? Yeah. I'm thinking, what's my reference angle? And then when is cosine negative? Right? So I know I need pi over 3s, right? I need those pi over 3s in quadrants 2 and 3. Right? All students take calculus if they pass pre-calculus, right? So I know in quadrant 2 and 3, sine is positive and tangent is positive, but cosine is negative, right?
The line between quadrant 1 and 4, that's negative? Looking at negative?
Yeah, the piece of cosine is underground, negative. Right? -1/2 would be right here, right? -1/2. So where does it hit on cosine curve in quadrants 2 and 3? Yes. 2 pi over 3 and 4 pi over 3. Yeah. Who is missing today? It's Marvin, Andrew, Brian G. Say again? One more time.
Andrew said he's not on.
Oh, you're right. He did say that. Thank you. Nice. Thank you. I remember him saying that. And I told him I'd record, and I am recording. And the audio is working. Finally got it all figured out. Only took me half a semester. Cool. We're ready. So that's for quiz 13 and 14. Just to have you look real quick at my schedule here, I've written out for the rest of the semester. Next week is quiz 13 and 14, always on Thursday. So the next 3 Thursdays we'll have quizzes. We'll have 18 quizzes when we're done, and then I'm going to count your best 10 quizzes. I'm giving you a gift like you wouldn't believe. I'm going to count only your best 10 quizzes. You're going to give me 100% of your homework, right? I mean, it's going to make some of you squeak by with a C. And do I care? Not really. I'll give you a C. I don't care. But how are you going to do in Calc 2? That's the worry. If you, because I'm giving you drop quizzes and extra credit and homework should be perfect, you got a kind of a padded grade a little bit, you might end up squeaking by with a C. But then what's going to happen with you if you only know 30% of the material? How are you going to do in Calc 2? You're not going to make it. Okay? So you've got to be serious. You have to know Chapter 3 inside out, backward, forward, as quick as you can. Right? And then Chapter 5, the same thing. Okay? Let me look at WebAssign real quick. I want to see what problems I like in Section 4.2. Yes, I have an answer. Which one?
So like for the graph,
Yeah.
like you see, it's like M. Letter
Yeah.
M. Yeah. So like the local minimum.
Yeah, so the local mins are here, here, and here if I included 2 pi.
Oh, I mean the higher, the
The middle one.
yeah.
Yes, what about it?
Like what's that one?
Well, you have to plug it in. So we know that's at pi, right? So y equals sine squared of pi minus cos of pi. Yes? Sine at pi we already know is 0. Cos of pi we know is -1. So we get a height of 1. Yes, Min? It doesn't sound very convincing. Yes.
Like I do that.
So on Desmos, I'm going f of x equals sine squared x. Oops. Minus cos of x. Restricted on 0 less than x less than 2 pi. And you can see that middle height is at 1, right? So, but we're going to graph it. So graph pi, comma 1, and see if we get that. Man, you see it? Not so easy to tell what's happening at the local maxes, or in this case, the absolute maxes, right? You agree? I've got 2 I got 2 top of the hills, right? So and that's the highest point on the whole graph, so that's an absolute max, but we also call them local maxes. If I'm standing on top of this hill on the left side, and anyone real close to me will be at a lower height, right? In fact, how close do I care about? How far left and right do I care about when I'm standing at the top of a hill to know I'm at the highest point? Epsilon. I care about epsilon to the right and epsilon to the left. Really close to me. I don't care about far away in calculus, right? I care about that infinitesimal distance, really, really, really tiny, right? Delta. But what do I get when I plug in 2 pi over 3? So y equals sine squared of 2 pi over 3. That was one of my criticals, right? Minus cos of 2 pi over 3. Well, sine of 2 pi over 3 is, in quadrant 2, is positive, but what's the reference ratio? Rad 3 over, thank you, squared, minus cos of 2 pi over 3, which I already know is negative 1/2, right? So I get what, 3 over 4 plus 1/2. What? Huh? Pi? Oh, yeah, 5. Yes, thank you. I can't, I have my ears in, but I didn't turn them up. I got to turn them up. I'm sorry.
Is there any point that we put all 4 local and absolute?
It depends on what I ask you. If I ask you, yes. If you want the points, then I ask you for something, you got to give me what I'm asking for. On this one, I didn't ask for all these heights. I asked just for the criticals, right? But I'm doing the heights. So 5 over 4. I'm just double checking that I get that right. So 2 pi over 3, comma 5 over 4. And you see I get my absolute max, which is also a local max. Nice, here we go. Oh, what problems do I like in the book, right? What problems do I like in the book? So I want WebAssign. Click, 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 so many clicks. Thank God I have my password saved. If I get hit in the head, I'm in trouble, I'll tell you that. I don't know how I get my money out of the bank either. What little I have. So in the book here, for WebAssign, did I click it? I thought I clicked it. Nope. Looking at chapter 4, in 4.2 exercises, the problems I would like you to be practicing, which will get you ready for your homework, 5. 1 to... Yeah, 1 to 61 is fine. Number 1 to 61. So in 4.2, those are the problems I'd like you to practice. Yes, evens. Oh, sorry, odds, the ones with the answers, right? You could do evens too, but you'll have to check on Symbol Lab or go to the Learning Center. They have the complete solution manual at the Learning Center, Math Learning Center. I know because I gave it to them. In 4.3 for exercises, and be careful about these because they're very, very long problems to do, as you'll see me do them today. I like problems 19 to... I think it's 47. 19 to 47 and 4.3. Now, when you read the book for 4.3, it's going to tell you to do everything, first derivative test and second derivative test. So it's a total pain. When I assign problems to you, I'm going to say do number 19 first derivative test only. I'm going to say do number 33 local mins and maxes only. I'm going to say number 49, do the second derivative test only, all right? I'm going to, and you're going to follow my instructions, damn it. You're going to, when I tell you what to do, you're going to write it down and do what I tell you to do, right? This, by the 5th homework, you'll finally start to do that. Okay, here we go. Let me close some things. 4.2, someone tell me what I said already. 1 to 61. Thank you. 60, 61? Yeah. All right, let me start a new recording, just because I don't want the recordings to be too long anyway. And we're going to do our first derivative test.